For today, you're going to have to help me out a little bit. Remember, these verify can be done really an infinite number of ways. It depends on how hard you want to make it. The first thing that I notice right away is that tangent has x over 2, so it's a half angle. And then the other one just has x as the angle. So are those talking about the exact same angle? No, one's half the other one's, right? For example, if x happened to be, say, 50 degrees, then x over 2 is talking about 25 degrees, right? We really don't know, but what I want to do is have the left side be the same as the right side. So our options are, I would look at it this way. We can either try and get tangent of x over 2 to look similar to this side, or we can try and make the right side look similar to tangent of x over 2. Which way do you think is going to be easier? Yes? No, you can't multiply both sides by 2 because that's the angle. Remember, tangent is a special function that's saying to do something. Yeah, we can't do that. That's what I'm saying, because the angle is sitting there. We're told to do something very special to that angle. And we can't just necessarily turn around and double it. Okay? So look on here. I believe I just gave you a sheet that has, let's see, right here. Oh, there's tangent of x over 2 right at the bottom of the sheet I just gave you. That's why you don't have to get your notes out, because pretty much all your formulas that you could possibly need are on here. So tangent of x over 2 apparently is equal to because you told me that you wanted to kind of work with that side, so I will agree with you. The one reason I like that is now take a look at all of your angles. All your angles are now x. Okay, that's better. That's going to be helpful. Do you notice perhaps anything else? Yes. Yeah, that's a very good observation. What was said is that right now our tops here are really, really close, aren't they? They're almost the same, except, yeah, the left one has a radical on it. So that's kind of, well, not good. So if we could get rid of the radical, okay. Could we square both sides? Is that something we can do when we're verifying? We have two sides of the equal sign. Can we do that? Sure. Okay. So let's go ahead and do that. And when we square this positive and negative, what really happens? Whether it's a negative or a positive, when you square it, yeah, it goes away. So really what you're saying, that's a very good observation. I like that. So it's 1 minus cosine of x then, because it really housifies, right? 1 plus cosine of x. But if I square the left side, I have to, unfortunately, square the other side. And that depends on how you want me to write it. You have to square the entire side, correct? It's not just cosine that's getting squared, though. It's 1 minus cosine that's getting squared. Well, it's not really the identity, because it's not just 1 minus cosine squared, because if I actually took 1 minus cosine and took it times itself, I would have to FOIL. But that's good. You saw the square, you saw the 1, and you're like, identity. Not quite. Because it doesn't say just 1 minus cosine squared. It's saying take 1 minus cosine times 1 minus cosine. That's what it says. We'd have to FOIL, and so that's why it doesn't work out that way. And I'm guessing most of you don't want to FOIL that. Is that pretty accurate? Okay, well, let's not do that. Well, really, the tops are still very similar, except now we have a square as a problem. So we'll get right back to where we were the step before. This could take a while if these are the choices we're going to be making. Foiling could be an option, but then it's going to get really long, and it's going to get further away from 1 minus cosine. Randy, can you just say that a little louder? You kind of trailed off there. That's what I just kind of showed that you can't do. Well, that might be helpful, but here's probably where I would go. Can you square top and bottom separately then? Can you do that? Well, it is, but it's going to get you closer. I'm pushing you in the right direction. This is the way you chose to do it. Well, I'll show you my way after this. It might be. I would still not foil the top. I'm going to try and push you in the easier direction now. Trust me not to foil the top on this one. Yes? Yeah, not quite. You're close. Can the bottom be sine squared? Can I actually write the bottom as just sine squared if I wanted to? Because is there any foiling on the bottom? No, I'll go with that. Let's write it as sine squared. So we're gonna squash this whole top thing right now. If I had x plus 1 squared, is that just x squared plus 1? No, you have to FOIL it. It's x squared plus 2x plus 1 if you FOIL it. Agreed? So if I'm going to FOIL this, I'm going to end up with the term in the middle, correct? And is that term in the middle going to match up with my top on the left? No. So do we want to do that? No. So we're gonna squash that idea. Here we go. Yes. Take the bottom times the top. So you want to write sine squared as 1 minus cosine squared?
1 sine over 1 times receive.
I wouldn't do that. Nope. Yes? Can we? What is sine squared's identity then? It's equal to what? Well, that's actually a good idea. I know it looks like a horrible idea, but it's a great idea. Do you agree that's the identity we're talking about? And can we get sine squared by itself? How are we going to get sine squared by itself? Okay, so you do agree that anywhere I see a sine squared, I could replace it with 1 minus cosine squared. Do you agree with that? That's actually going to be an excellent suggestion. That's where I was trying to push you. And some of you are saying, I still don't know why, and I don't blame you. If I was in high school, I would not have seen that little maneuver. Believe it or not, you are extremely close to this answer. You are almost done with this problem. No, but close. No, the ones do not cancel. And this is saying 1 minus cosine. Here, I'll show you. I'm going to write this a different way. It's 1 minus cosine times 1 minus cosine. Okay, that's what it's saying. This is 1 minus cosine squared. Unfortunately, they do not cancel because this cosine here is squared. Those up there are not. And if you see this next one, you're ahead of the game. And then I'll show you how I would have done it. And then you're going to get really mad. 1 minus cosine squared is a difference of 2 squares. If I take 1 minus cosine squared and make it a difference of 2 squares, 1, cosine, cosine, you agree with that? 1 plus and 1 minus? Ooh, I said it right and wrote it wrong. Do you agree that's what it could be? And I almost did it again. Now start talking to me about canceling. Because now stuff actually can possibly cancel. Does that match that exactly?
Exactly to a T.
Now look at the left side of your equation and compare it to the right side of your equation. Oh, sorry. I would leave my answer like this. So pretty tough, but I did want to show you the difference of two squares, which is why I was pushing you in that direction. I liked the ideas that you had. And yes, this is probably where, when you see how I would have done the problem now, you'll get slightly upset.